Okay, so our next bit of notes we're going to take today are over, we'll close up the Arrhenius and Bronsted-Lowry flap, and we're going to go ahead and open the acids and bases math flap. Okay, so we're going to start with a diagram, kind of a helpful guide like we had with stoichiometry. Okay, so we're going to start off with a hydrogen ion. Okay. So if you are given the concentration of hydrogen ions or something called a hydronium ion, okay, we're going to show you how to get to how to figure out the pH of that substance. So we're going to go and get to pH. pH is our ultimate goal here for everything. We're trying to figure out what our pH is. Okay. So we are stopping at pH. That's our goal. So if we're given with concentration of hydrogen ions, all we're going to do is put in the calculator log and then the concentration of hydrogen ions. So negative log and then hydrogen ions. Okay, so one step, easy peasy. Now we're not always given the concentration of hydrogen ions. Sometimes we're given the concentration of what are called hydroxide ions. Remember, hydroxide are OH ions. So if we're starting here, we will never end on this side. So if we're starting here and we want to get to pH, our first stop, we can't go directly to pH. We have to have a quick stop at POH. So the POH again is just how many hydroxide ions we have. So, or basically. So we're going to go get from the concentration of OH ions to the POH by going through negative log OH. So just like we did before. And I will show you examples so you know what I'm talking about. So we will never stop here. We will always keep going until we get to pH. Okay? So the question is, how do we get to pH? Well, once you figure out the POH, it's pretty simple to get to pH. Because on a scale of 0 to 14, to get to the pH, all you have to do is take 14 and subtract whatever the POH is. So that part's pretty easy. So let's start by doing a couple of examples. So let's say we're starting here with the concentration of hydrogen ions. So they give us a concentration of 2.62 times 10 to the negative 3. Okay? So to figure out what the pH is, we're just going to use this little formula here, negative log 2.62 times 10 to the negative 3. Okay, and I'll show you how to put that in the calculator. And just turn on the calculator. So negative, so the negative button, and then the log button, so that one right there, it gives you log, and it opens up the parentheses. Then we go ahead and put in the 2.62, and then remember how we did scientific notation? The easiest way was to hit second, and then the comma, giving you the double E, the big E, okay? And then we go ahead and put in the exponent, which was negative 3, and then hit close parentheses. Hit enter, and our answer is 2.58. So our pH is 2.58. Now remember, less than 7 means it's an acid. So this is an acid. So let's do another example. We're going to do one where we're starting here. They give us the pOH, and we forgot the pH. So in this example, our pOH is 5. Okay? And we want to get to pH. So remember, to get to pH, you take 14 and subtract the pOH. So our pH would be 14 minus 5. And that would give us 9. So remember, greater than 7 is a base. So this is a base. So then our final example is if we're starting here with the hydroxide ions, we have to move down, get the pOH, and then use that to get the pH. So that'll be our last example. So they give us a hydroxide ion concentration of 3.73 times 10 to the negative 8. Remember, we have to get our pOH first, and to do that, we use negative log OH. So we go negative log and then put in the 3.73 times 10 to the negative 8. So when we put that in the calculator, do the same thing, negative log 3.73 second, double E, and then our exponent is negative 8. Close those parentheses and hit enter. And we get 7.4, and we can round that to 3. So our pOH is 7.43. Now we're here, and remember we never stop here. We want to keep going till we get to here. So what we're going to do now is take the 14, subtract what we got for the pOH, and that will give us the pH. So let's go ahead and do that. So pH is equal to 14 minus pOH. So pH equals 14 minus 7.43 of 6.57. And since this is less than 7, it's very close to 7, but still less than 7, this is still considered an acid. Okay, and those are our calculations for acids and bases. They look a little scary at first, but once you get the hang of them, they're pretty easy.